Welcome to the fifth lecture in the open online course Computer Numerical Control of Machine Tools and Processes. We will be having discussions, multiple choice questions and numerical problems on the first 4 lecture material. Let us see. Let us have this one. In the x axis of a point to point open loop CNC table employing pulse generator, stepper motor, gearbox, lead screw, the gearbox ratio is changed from half to 1/4 and the pulse generator pulse rate is doubled. So, there are two changes. Gearbox is changed from half to 1/4 and pulse generator rate is doubled, and the choices are, as a result, the x axis basic length unit will double, the x axis speed will double, the x axis speed will become half and none of the others. Okay. So, let us keep in mind two things: gearbox reduces from half to 1/4 and pulse generator pulse rate is doubled. Let us see. First of all, the basic length unit, which is the distance covered by the table per pulse of the pulse generator, it is not affected by pulse generator frequency. Why? Because whether the pulse generator frequency is fast or slow, the distance moved per pulse by the table will always be the same. With this thing in mind, we can say for one rotation of the lead screw, for the one rotation of the lead screw, the table motion will be equal to the lead of the screw, equal to say L. So, in the second case, for 200 pulses, one rotation of the motor shaft gives rise to 1/4 rotation of the lead screw due to the presence of the gearbox, which gives rise to L/4 millimeters of movement of the table. So, second case, for 200 pulses, the movement is L/4, and therefore, the basic length unit in the second case will be L/800 by unitary method. 200 pulses L/4. So, 1 pulse L/800. In the first case, the gearbox is different. Therefore, for one rotation of the motor shaft, we have half a rotation of the lead screw, and hence the table movement will be L/2 for 200 pulses. Therefore, the basic length unit in the first case was L/400. Why? 200 pulses giving L/2, therefore, 1 pulse giving L/400. Obviously, the basic length unit is halved in the second case with respect to the first case, because it is becoming L/800 from L/400. Is it one of the options? Let us take a quick look in the previous slide. Basic length unit becoming half? No. So, up till now we have not identified the correct answer. Basic length unit is half, is double. This is definitely wrong. The first one is wrong. Coming back, in the second case, let us find out the speed. The frequency is twice f, divided by 200 gives us the number of rotations of the stepper motor shaft, multiplied by the gearbox ratio 1/4 gives us the lead screw rotation, multiplied by L gives us the table movement. Therefore, we have, collecting all the terms, we have F/L/400. That is good. And in the first case, therefore, it will be F/200 giving the motor rotation, multiplied by half, that gives us the lead screw rotation, multiplied by L gives us F/L/400. So, essentially the speed is remaining the same. So, let us go back and let us now find out the correct answer. The x axis basic length unit will double? No. The x axis speed will double? No. The x axis speed will become half? Definitely not. Therefore, the correct answer is none of the others. None of the others. Okay. Let us take this problem. This seems to be quite formidable. In a point-to-point open loop CNC drilling machine, a stepper motor drives the table in the x direction, and the stepper motor shaft is connected to a gearbox with ratio. Ratio is defined as output RPM by input RPM. Ratio is 1/4, which is in turn connected to a lead screw of pitch 4 millimeters and number of starts equal to 2. So, as we have discussed before, if a lead screw has pitch equal to 4 and number of starts equal to 2, the lead, that is the movement which the nut will execute per rotation of the lead screw, will be equal to 4 into 2. Okay, N into P equal to L equal to 8 millimeters. The stepper motor covers one rotation in 200 equal steps and executes one step per pulse. One step per pulse of pulse generator. The pulse generator frequency is 100 pulses per minute, received by motor driver. The pulses output from AND gate go to motor driver and also to a position down counter. These incoming pulses, that means incoming into the position counter, decrement the content of the position down counter. In what way? One pulse comes in and position down counter content goes down by 1. The questions are, what are the basic length, unit and velocity of the table along x axis? Second, what number in binary will the MCU, that means machine control unit, put into the position down counter for executing line number 2 of program above? So, there are 3 questions. First of all, let us see how the system works. If we are putting in some number, so first of all, let us accept the machine control unit is capable of putting in some number, okay, setting it to a particular number as it pleases. So, we have to decide what that number should be corresponding to line number 2. But first of all, let us find out the basic length unit and let us find out the velocity of the table along x axis. First of all, what is the basic length unit? We have 200 steps of the motor. Let us say, I think we have worked out, answer is basic length unit is equal to 8 millimeters, that means the lead of the lead screw divided by 800 pulses. One rotation of the lead screw must be requiring 800 pulses of the pulse generator. Why so? That is because one rotation of the lead screw is obtained from 4 rotations of the motor, because the gearbox ratio is 1/4. So, 4 rotations of the stepper motor produce 1 rotation of the lead screw, resulting in 8 millimeters of table movement, and 4 rotations of the stepper motor will require 200 into 4 equal to 800 pulses. So, 800 pulses giving 8 millimeters of movement. So, that means the basic length unit must be 8 divided by 800 equal to 0.01 millimeters equal to 10 microns. So, basic length unit is equal to 10 microns. What is the velocity? Velocity is easy to calculate. Once you have got the basic length unit, it is simply equal to basic length unit into pulses per minute. Okay. So, these many pulses per minute will produce these many basic length units per minute, and together this will be 0.01 into 100 millimeters per minute. Okay, 100 pulses per minute, that means millimeters per minute. Okay. So, this is millimeters per pulse and this is pulses per minute. So, that becomes millimeters per minute, and that means 1 millimeter per minute. But why are we moving it in such a slow manner? This must be a microsystem equipment, okay, microsystem equipment. So, it moves 1 millimeter per minute, this is the velocity with which it moves. And what should be the number which should be put in binary inside position down counter? For this, let us quickly go back and have a look how it works. This one position down counter, once it is loaded with a number, unless and until it is counted down to 0 by these incoming pulses from the AND gate, unless it becomes 0, it will never send out a 0 as the output of the OR gate, and that will never be able to stop these pulses from coming in and entering the position down counter, and these pulses incidentally are also being sent to the stepper motor. So, when you have sent the required number of pulses to the stepper motor, this should stop. So, that means those many pulses counted in binary should be put here, so that they are decremented and consequently further pulses will be stopped. So, let us find out, in order to carry out the second line in command, how much should be the number of pulses or number of basic length units to be moved along x axis. Sorry. So, previously in line number 1 we were at x equal to 20 and now we are at x equal to 25. So, naturally we are executing 5 millimeters of movement, and how many basic lengths should it be? It should be equal to 5 divided by 0.01 equal to 500. So, if we put 500 in binary in the position down counter, after those many pulses, further pulses will be stopped by end of count from reaching the motor. Okay. Thank you. Next, see a similar problem in closed loop control, point to point still, but closed loop control. So, let us have a look how it works. Let us have the same problem here and let us try to solve it. What is the problem? Find out the basic length unit, velocity and number to be put inside PDC to execute that same command. Okay. First of all, let us see how this works and in what way is it different from the previous one. Here the down counting of the position down counter is done by the encoder. Okay. The encoder pulses are coming, these pulses are entering the position down counter and making it 0. Once it becomes 0, further movement of the DC motor will not be possible. So, let us plan it in this way, that the number of basic length units corresponding to that, when the number of pulses are sent corresponding to 5 millimeters of movement, after that this will be counted down to 0. So, let us first of all find out how much is the basic length unit. Here the lead screw pitch is 4 millimeters and it is single star, okay, slightly different from the previous setup. So, 4 millimeters of movement is being carried out due to one rotation of the lead screw, and at the same time 200 holes are passing in between the light emitting device and the photoreceptor. So, 200 holes correspond to 4 millimeters of movement, therefore, one hole corresponds to 4 millimeter divided by 200. Let us see how much it is. That is right, 4 millimeters divided by 200 is equal to 0.02, which is nothing but 20 microns. So, the basic length unit is 20 microns this time. What is the velocity? What is the information given about the velocity? Let us have a quick look. DC motor rotates at 100 RPM. Okay, by some means we are making this DC motor rotate at 100 RPM, and corresponding to this we are developing a definite velocity. We have to find that out. So, how do we do that? So, DC motor rotating at 100 RPM will have a transformation through this gearbox, which is 1/4. So, this must be rotated at 25 RPM, and if it is rotating at 25 RPM multiplied by the pitch, that will be 100. Okay. Let us see the answer. Yeah, 100 RPM multiplied by 1/4, which is the gear ratio, multiplied by 4. So, how much is that? That is equal to 1 millimeter per minute. Why so? Just one moment. 4 millimeters of movement, 100 RPM. So, I think there should be it should be 100 millimeters per minute. Okay. Please correct this. It should be 100 millimeters per minute. Achha. Now, let us look at the I am sorry, this is let me see, velocity is 100 RPM. So, with every rotation 100 RPM is converted to 25 RPM for the lead screw, and 25 RPM multiplied by 4 will be giving us 100 millimeters per minute. Okay. So, if we have 100 millimeters per minute, please note it down and I will correct it in the final lecture. Number in binary to be put inside the position down counter. Okay. 5 millimeters of movement have to be realized and one basic length unit is 0.02. Therefore, 250 should be residing inside the position counter. Let us see, this is the position down counter. After 250 pulses have moved through, after that this comes to a stop, because end of count will be sending out 0 and therefore, the motor will be stopped from further movement. Okay. So, this is 250 in binary should be put inside the position down counter. I think we have time for a few more problems. Let us take this one. In a Techno Fest for Innovative Designs, a student demonstrates a surface roughness tester he has developed. So, this is a surface roughness tester the student has developed. How does it work? It has a nut of 1 millimeter pitch and it is connected to the stylus which records roughness values on a rough surface, which is shown on the left side, and this nut is made to move by a lead screw which is being operated from a stepper motor through a gearbox of ratio half, and pulses of frequency f, they are being sent to the stepper motor to make this work. So, surface roughness testers generally work this way. The stylus will move forward and then again come back to its starting position, and in between it will record some values of ups and downs, crests and crevices, so that this data will be processed to find out the roughness of the surface. So, the student has developed this through devices that we are conversant with. So, let us have a look. The stylus is moved with velocity v by a distance of 4 millimeters. So, the movement that the stylus is executing is 4 millimeters and it collects n number of profile data, one profile data for each step of the stepper motor. Stepper motor moves one step for each pulse and covers one rotation in 200 steps. The frequency of the pulses f equal to 20 hertz. Pitch of the lead screw is 1 millimeter. So, the questions are, find out the value of n and v. N is the number of readings it is capable of taking for the 4 millimeters of movement, and v is the velocity of the stylus, and what is the distance covered by the stylus between two readings. This corresponds to a basic length unit. So, this should be easy. So, let us try that. First of all, basic length unit, how much should it be? So, the stepper motor rotations, 200 steps will be rotating as the gearbox ratio is half, rotating the lead screw by half a rotation. Therefore, half a rotation will amount to 0.5 millimeters of movement. So, 200 steps giving 0.5 millimeters of movement. Therefore, one step should give 0.5 divided by 200. Therefore, distance between successive readings equal to basic length unit equal to 1 millimeter by 400, that means 0.5 by 200 equal to 2.5 microns. So, this is the answer to the question number 2. Number of readings in 4 millimeters. So, it is simply divided by the number of basic length units. So, 4 divided by the basic length unit is 1600 readings will be taken in a distance of 4 millimeters. And the velocity once again is equal to basic length unit into pulses per second equal to 0.0025 into 20, which means 0.05 millimeters per second equal to 3 millimeters per minute. Okay. Thank you. This is perhaps the last question that we can manage. Let us have a quick look. What does it say? It says that a company publishes a tender inviting quotations for a CNC point-to-point control table which moves only in one axis. So, it is sometimes called a single stage. That is fine. The basic length unit is to be 5 microns and the axis velocity is to be 100 millimeters per minute. You represent another company which builds and sells machines by assembling different pieces of equipment. And where are these equipment available? You can refer to table 1 and it will show you the equipment which is available with you. Check whether you can build a machine to satisfy the above requirements using one pulse generator, one stepper motor, one gearbox and one table. Now, first of all, verify whether there is any chance that your quoted price, assuming you want to make a profit of only 1000 rupees for the CNC point to point control table, would be the lowest. So, what is exactly required here? We have to choose from this inventory of equipment which is available with us some equipment which is restricted to one pulse generator, one stepper motor, one gearbox and one table to make up finally this CNC machine, which is going to be capable of producing a basic length unit of 5 microns and an axis velocity of 100 millimeters per minute. And then by adding up the price and adding a profit of 1000 rupees, we have to find out whether we will land the purchase order or not. So, let us first have a quick look what is available with us. We have a pulse generator, I mean 2 pulse generators and their frequencies are given to be 22,000 and 20,000. Can we use any of them? Well, we can use any of them provided that we can attain the specifications which are laid down in the tender. That is fine. Stepper motor, there is only one, so we have no choice, we have to go for this. Gearbox, there are 2 gearboxes, one is having a ratio of 1/4 and another is having a ratio of 1/3. Table with lead screw nut pair, which is having a pitch of 4 millimeters and there is a table with a pitch or lead, whatever you call it here, it makes no difference, of 3 millimeters. So, gearbox we have option, pulse generator we have option and table with lead screw we have option and they have different prices. So, let us see how we can make up the cheapest machine which is capable of providing the required basic length unit and axis velocity. So, first of all, as we have discussed in 2 previous questions, basic length unit is not affected by pulse generator frequency. Pulse generator, so basic length unit, let us calculate it. Basic length unit is the table movement per pulse and therefore, we have one pulse of movement creating 1/200th of a rotation of the motor shaft, creating into u being the gear ratio of lead screw rotation and that is leading to multiplied by p these many millimeters of table movement. So, this is the table movement per pulse and it should be equal to 0.005 millimeters. So, if we simplify, collect all the terms properly, we have p into u divided by 200. So, we have written here p into u divided by 200 should be equal to 5 microns, which gives us p u equal to 1. The axis velocity on the other hand is going to be the frequency of the pulse generator divided by 200, giving us the number of rotations of the stepper motor, number of rotations of the stepper motor multiplied by the gear ratio, giving rise to the number of rotations of the lead screw and multiplied by p, giving us the total amount of movement per minute of the table. So, this is the axis velocity in millimeters per minute, and it should be equal to 100. We are equating this thing equal to 100. So, we get essentially two equations, one is P u equal to 1, and from here we can put P u equal to 1. So, that F will be equal to 100 into 200, which means 20,000 pulses per minute. Now, do we have a 20,000 pulses per minute generator here? Yes, this is the one. The item number 2, 20,000 pulses per minute, is the one pulse generator that will satisfy our requirements, and it essentially also means that the first pulse generator, 22,000 pulses per minute, it will not satisfy our requirements. So, that we cannot take it. So, this is the one pulse generator that we require, and that means it will be costing us 10,000 rupees. Cost price is 10,000 rupees. So, 10,000 rupees first of all is the expenditure for the pulse generator. Let us see the others, what option we have. Now, if P u is equal to 1, if it is to be equal to 1, let us see whether we have options giving us such a combination, P u equal to 1. Yes, if we choose gearbox item number 4 together with item number 6, we have 1/4 multiplied by 4 equal to 1. So, we could well choose this combination, but we could also choose gearbox item number 5 1/3 and gearbox item number this one pitch equal to 3 item number 7, 1/3 and 3 or 1/4 and 4. Which one would you choose? Both will be sufficient. I mean, both will be satisfying your requirements, but they are having different costs. So, obviously, let us go for the cheaper ones. So, 3,000 rupees here gearbox, 3,000 rupees for the lead screw nut arrangement gives us 6,000 rupees, together with that 10,000 that we incurred for the pulse generator, 16,000, and the stepper motor you have to take it anyway. So, 7,000 more, 16 plus 7 is 23,000. Add to that a profit of 1,000 rupees that we would like to have, and that is 24,000. Let us see. Yes, you win the purchase order, because your price is going to be 24,000 and it is going to be lower than any of the bids which are put forth by these 4 companies. Congratulations. So, you have won the purchase order for this particular equipment. Last of all, we have just a few minutes to finish one small problem. In a CNC machine with continuous control, the following commands are executed: G90, G00, X100, Y200, Z20, and after that. So, this is a rapid traverse command occurring at highest possible speed, and after this the tool is going to reside at 100, 200, 20. After that, we have a G01, that means linear movement, where X is 130, Y is 240 and F is 200. So, that means net X movement is 30 millimeters incremental and 40 millimeters along Y axis. So, 30 and 40. What is the feed of the cutter in the X direction in line number N02? So, let us have a quick calculation. Y is 40, X is 30, and therefore, this must be 50. This is the displacement triangle, and on top of that we are putting the velocity triangle. What is the velocity triangle? The velocity triangle says that this is 200. So, proportionately we can place, therefore, this is the feed along X axis. How much should this be? If it is 50, it is 30. So, multiplied by 4, and therefore, you have 120 here, and here you have 160. So, answer is the feed should be 120 millimeters per minute along the x axis for this particular command block. Okay, 120 millimeters per minute. Last one, incremental format, the feed along x axis corresponding to program line G91, which means incremental G01, X40, Y30, F100 is, it's absolutely the same problem, only incremental means these are the actual movements, incremental movements along 40 and 30. So, they will be just like the same problem. I am sure you can do this yourselves. Thank you very much.